Welcome to class. I'm ever ready. I like what someone said. He said I was born ready. Yes, I'm ever ready. Always here. We are going to be learning each and every day. And I've discovered that as a secret of success in terms of being a tech giant. I admire advanced tech people. And I did a research on how they became what they are. And I discovered that it is not because Black people cannot make it. It is not because Africans cannot make it. Africans can make it. We can make it. But we can make it through consistent learning. So never get tired learning. I'm not going to get tired learning and teaching. So don't be tired. Keep on learning, and you'll definitely get there. You are going to be so advanced, and you are going to contribute to the body of knowledge of global technology. That is what we are aiming at, and that is what we are going to achieve. So welcome, everybody. Welcome to the 14th of our AWS CCP certification examination and training. Today is the 14th, and we've been talking about databases. Databases are very powerful tools in tech, and every tech professional needs to have an experience working with databases. So good to see you, Yvonne, Jael, Marianne, Ashinafi. Keep learning hard. I can see Ashinafi trying. You are doing very, very well, and you are making the Ethiopians proud. So we are very happy to have you with us, and we wish you all the best. And we are going to give you all the support possible to make Ethiopia bright and make the whole country proud. So let's all keep working. Again, just like Benedine said, Greater Africa is a community of like-minded individuals who are headed towards the same direction. And so we are going to be working together as a community to get there. Yes. And our goal is to make sure each and every one of us succeeds, and we celebrate everyone. So we are here to celebrate your success. We are here to give you all the support, all the help you need so that you will succeed. That is the only way we can make it. And that is how we are going to do it. Last time I said that we're a fellowship, and just like a fellowship, we are fellows in a ship. So if we are fellows in, let's say, a boat, it's not only Benedine who should be rolling the boat. If only Benedine is moving us forward and everyone is sitting carelessly and not helping, the boat cannot move faster and cannot move well, and we will all be late. But if everybody rows the boat, we will all move smoothly and everyone will get to their destination. So let's begin building that sense of fellowship, sense of comradeship, sense of community. And in the next year, we are going to bring out a structure or elevate the sense of community in Greater Africa and talk more about it and make Greater Africa a big community. Yes, so it is so it's so fun and so wonderful to be part of this, and It is something that is going to make your life better, better and better. All right. So today we want to continue, and today we want to move into the world of NoSQL databases and talk about databases that are not relational. We have said over and over that we have two main categories of databases. We have relational or table-based databases with relationships, and we also have non-relational databases, like what we call NoSQL. And for so many years, we've been working with structured relational databases. And today, the other type of database, or the other type I mentioned, is also advancing. So NoSQL databases are rapidly advancing. And so as tech professionals, we need to open ourselves to that, and we need to learn that as well. It is not that relational databases are not okay. It is not that relational databases are outdated, but the fact is that relational databases have its special use cases, and non-relational databases also have their special use cases. So you can never, ever ignore relational databases or non-relational databases. Sometimes when we are advertising one of them, we tend to hype it more than we should, and we tend to speak less of the other. But the fact and the reality and the truth is that they are all super important. As a matter of fact, if you don't know relational databases, I don't think you are going to make much progress. So you need to learn and especially begin with relational databases, build a strong foundation in relational databases, and then you also learn non-relational databases as well. So I'm going to start with a video, and this video will talk a little bit about non-relational databases. It is going to hype it more, but again, it is not because relational databases are outdated, obsolete. It is just because there are specific use cases for each one of them. So let me share my screen quickly and we will get right into it. Let's watch a short clip about non-relational databases and we will continue.
For years, SQL databases were the only path forward. But in the age of digital transformation, NoSQL databases can go where SQL can't. SQL allows data in tables to be sifted through by queries, a traditional way to store and retrieve data that worked well in the past. But after 50 years of experience, we know all the baggage that comes with SQL that slows development and makes scaling hard. The web, mobile devices, and digital transformation make speed of development and scaling must-haves. NoSQL databases were invented to meet those needs. NoSQL databases come in different models, but the document database leads the race due to its strengths in rapid application development, collaboration, and horizontal scale-out. MongoDB Atlas is the leading cloud document database platform that stores, distributes, and indexes data in flexibly structured JSON documents that map naturally to application objects. Flexible schemas handle any type of data and supercharge agile development. The document structure enables a powerful scale-out model that can handle huge databases and lots of traffic. MongoDB Atlas works in all the major public clouds, with extensive automation and a user experience developers love, so your teams focus on creating value, not on administration. MongoDB Atlas is the central product of the MongoDB Cloud, which also supports mobile development and data lakes, with built-in search and data visualization. MongoDB Atlas is strongly recommended by leading analysts, used by innovative corporations worldwide, and is the most wanted database by developers. When you need applications that go farther and faster than SQL can manage, MongoDB is the document database to get you there.
All right, so after today's lesson, And today and tomorrow, we are going to be talking more about NoSQL databases. And what you are going to discover is that this type of databases are becoming more and more popular, and modern developers, modern applications are moving towards NoSQL databases. Again, it does not mean at all that relational databases are not important, are obsolete. It does not mean that at all. The only thing is that when it comes to certain high-performing environments, NoSQL databases are designed in a way that they can easily scale. They can easily become larger without intensive compute resource usage. And so they have a little bit of flexibility in terms of how their structure is and how, no matter the workload, they can still work flexibly. We have to understand that there are a lot of applications today that prefer NoSQL databases like MongoDB or DocumentDB or DynamoDB that we'll be looking at today. However, relational databases are required for so many other use cases and are so important. So like I'm saying, you don't have to ever send your mind to NoSQL not being good. You should never, and you can never think about that. As a matter of fact, the first database service of AWS is the RDS, the Relational Database Service. All right. So as tech professionals, we need to understand what exists, understand what is modern, and understand how to approach our studies and our learning towards the cutting edge technology. We are going to get into our studies today, and we are going to focus on what we call Amazon DynamoDB. And we are going to discover how DynamoDB is a NoSQL database. And we will see the type of NoSQL it is. And I'm going to begin by talking about the different types of NoSQL databases. So we are going to discover about 4 different types of NoSQL databases. And when you look at the AWS database services, these two over here, DynamoDB and DocumentDB, these two are the NoSQL databases. AWS's most powerful database service, Aurora, that is cloud native, it is a relational database service. RDS is also relational. Redshift is also relational. All right. So we have to think of them as important for different use cases, okay, depending on what you are working on. All right. So what I'm going to do right now is to mention what databases are. And we mentioned that they are relational and non-relational. We know that by now. And relational databases are databases that store data in structured tables, organized into rows and columns. And they can establish relationships. So I showed you several pictures and several explanations. We have several database platforms that are relational, like MySQL is the most popular relational database platform for building web applications. So if you have built a website that uses a database, you have set up MySQL before. If you have a control panel to host your website, or your web hosting server provides the software called cPanel, you will see that we have MySQL in it. With that, you can just create a database by entering the name of the database you want. Once it creates, you establish the user privileges, and then you can start working with that database. You go ahead and use a tool like PHPMyAdmin. You go ahead and you create a table. You design your fields and your records, or the fields and the tables. Then you can start entering your records, which is the real data you put in. When it comes to non-relational databases, what we call NoSQL, these are databases that handle unstructured and semi-structured data. They are highly flexible and scalable, using formats like key value pairs. And when we say key value pairs, you can think of Python dictionaries. If you are familiar with Python and dictionaries, you can see how dictionaries operate with key value pairs. They can also store data in documents or graphs. So these are different formats that NoSQL work with. Examples of NoSQL include MongoDB, Cassandra, and Redis. These are popular examples. In the world of AWS, we have DynamoDB and DocumentDB, which we'll be looking at. So I mentioned that there are 4 main types of non-relational databases. So think of non-relational databases as non-table databases, and these are databases that do not form relationships the way tables form relationships. Now, the way tables form relationships allow us to be able to retrieve data from multiple tables at once. But what happens is that in super high performing environments, because we need to work with multiple tables to be able to get results, it slows down performance. With key value pairs, they've been designed in a way that data can be pointed to only the specific data we are looking for in a way that it doesn't have to operate with multiple, or it doesn't have to rely on multiple relationships to work. And also, because of how they are designed, more can just be added with ease, making it much more flexible. So we have 4 major types. We have the key value pairs, or what we call key value stores. Then we have graphs, we have a wide column, and we have document databases. So what we take from this lesson is that we understand relational databases, and we have non-relational databases, and there are 4 types of them. Over here, we have an example of the non-relational database, and this is like a document non-relational database. Let's look at them much more closely, and let's see their examples. So I'm going to play one short clip. After the clip, we will look at the types of non-relational databases and explain it much more further. So I'm going to share my screen, and I'm going to show you these databases.
Hi everyone, I'm Yamini. So what is a NoSQL database? A NoSQL database is a non-relational database, which unlike relational databases does not store its data in tables with fixed columns and known data types. Instead, it uses documents with data type descriptions and values to store data. A NoSQL database has a dynamic schema for document types. What this means is you do not have to explicitly mention the form of your data before storing it. So this kind of database can handle unstructured data really well. NoSQL databases use a hierarchical data storage. So as your application grows and you start to add new fields, your schema evolves as needed. So this database is scalable horizontally. So if you need to build something really quickly or are in an early stages of prototyping a new application, NoSQL is a good way to go.
All right. So we've heard a little bit about NoSQL or NoSQL databases. Let's read something about it. Now, it says that NoSQL databases are non-relational database systems designed to store and retrieve data without the use of traditional table structures. Now, as a beginner, what you should take from this is that we have table-based databases that recognizes relationships or establish relationships. Those are relational. And we have non-table-based, non-relational databases. And so the NoSQL, what it is trying to communicate is that it is different from the relational model. All right. How is it different? It is saying that any database that is not relational is NoSQL. So NoSQL is not really talking about one way of storing data. It's talking about a group of ways of storing data that is different from the relational model. With the relational model, we use tables, period. We create entities in the database and we establish relationships between them, just like I explained in our previous lesson. Apart from that model, any other type of database that doesn't follow that model is NoSQL. So we are going to see what the NoSQL stands for. Now, NoSQL actually means not only SQL. That's what it stands for. Referring to a class of database systems designed to handle unstructured or semi-structured data, unlike traditional relational or SQL databases. Now, with the relational databases, we use a language called SQL to manipulate and to retrieve data. And so, if you want to fetch data from the database, you need to write a query in a language called SQL. This is a very popular and a widely used programming language or a query language. We don't call it programming language. You can say query language to retrieve data. When you have a database, it's just like a warehouse. You don't use everything in the warehouse when you need something. When you need something, you only pick what you need. So when it comes to fetching data from databases, we only retrieve what we are looking for now. And so when we write a query, the query will go and communicate with the database and only bring out what we need. All right. The NoSQL is trying to tell you that anything that is not SQL, for some of them, there are ways of retrieving data that is similar to the way you write a query in SQL. There are about 4 main types of NoSQL. So just like I said, any database that doesn't follow the relational model is NoSQL. There are 4 types. One is called key value store. Key value store. Please type that in the chat. Key value store. Key value store. So if you're a beginner to databases, for this examination, just do your best to distinguish and look for the keywords. When you hear table, when you hear relational, you should know that we are talking about relational databases, and that refers to the SQL databases. In AWS, that refers to RDS, Aurora, and Redshift. When you hear NoSQL, when you hear unstructured, when you hear semi-structured, when you hear not relational or unrelational databases or non-relational databases, you think of the NoSQL databases. And in AWS, we have 2 of them, and that is DynamoDB, and we also have DocumentDB. Now, we are talking about NoSQL in general, and we have mentioned one. The first one is called key value store. And an example is what we'll be learning today, called DynamoDB. Now, the key value store or stores store data as key value pairs. It stores data as key value pairs, allowing for fast and simple data access. And so just like a picture here, we have a key and then we have a value. And so if you remember how Python dictionary works, if you want to retrieve the data, you just need to have the key and then it will retrieve the value for you. So it stores the data that way and not in tables and not with a table structure. Let's keep this in mind. We'll talk about it again. We also have another one called document databases. Please put that in the chat for me. Document databases. The most popular example is MongoDB. It stores data in flexible JSON-like formats, such as BSON. And this BSON is a format that MongoDB structures its data. So a MongoDB data structure or data format is called a BSON, making it suitable for handling complex data structures. All that we are going to learn today, as a beginner, there are some key details that you need to pick out to distinguish between them, because when you get a question about these databases, you are going to be asked questions that you would have to look at all of them and know whether they are referring to relational or non-relational. And the possible answers, you look at which one is relational and non-relational, and you map that to the question to get the right answer. As a beginner, just try and pick the differences, which will help you very much. As you progress, we are going to get detailed understanding and hands-on experiences with these types of databases. MongoDB is super popular today, just like the video we watched. And I'm going to play another video about MongoDB, and we will continue. When we get to DynamoDB, we are going to learn that it is both a key value store database and it is also a document database. After we watch this clip, we are going to talk about two other types of NoSQL databases. And by the end of this class, I'm going to ask you to give me the four main types of NoSQL databases. Right now, we have seen two of them. Just keep them in mind. We have the key value stores, and it stores data as key value pairs. This makes a lot of sense. Document stores data in flexible documents or in flexible formats like JSON. Because JSON is very popular, when we say JSON-like formats, we get an idea of how it is. And just like the first picture I showed you, that gave you a relational and non-relational. This is a JSON-like document. With this format, it is much more flexible and easy to retrieve and to scale with it. Let's watch this clip, and after that, we will talk more about it. So let me share my screen now, and we will watch it.
MongoDB is the world's most advanced and popular document-oriented database. It was created in 2007 after the team at DoubleClick, a company serving 400,000 ads per second, faced issues with scalability and flexibility using existing database systems. This inspired them to design a database where all data is stored in JSON-like documents, which are organized into collections where they can be queried. Unlike a relational table, a predefined schema for a collection is optional, which allows you to evolve your data structures rapidly without running complex database migrations. But more importantly, it allows data that's frequently accessed together by an app to be stored in the same place. This makes read operations extremely fast because no joins are required. It's like having a fully assembled car ready to go as opposed to joining together a bunch of separate parts. And that also makes the database much easier to scale horizontally via sharding. Unlike relational tables, collections are self-contained, making them much easier to work with in a distributed system. That's why they call it Mongo. It's designed for humongous workloads. When you create a new document in MongoDB, it's assigned an object ID that's unique to that collection. Inside the document, you can define multiple fields, where the value might be a variety of different data types like a string, array, object, and so on. Now, to work with your data in any programming language, the Query API is used to perform basic read and write operations, as well as complex queries and transformations across the database. To optimize performance, secondary indexes can be created to make common queries extremely fast. It also supports geospatial queries to find all the documents near a geographic location. In addition to queries, you can also create data aggregation pipelines, which can group documents together and reduce them to a single result. MongoDB is free to use and can be self-hosted, but the quickest way to get started is with the free tier on Atlas. It scales automatically and provides a UI where you can interact with your data, plus a ton of other awesome features like full-text search that leverages the power of Apache Lucene. In addition, they just launched a serverless option where you only pay for the exact resources that you use. And Atlas has other essential features like triggers that make it easy to run serverless functions when your underlying data changes. Then there's Realm, which is a Firebase-like platform that makes it easy to sync up your data with a front-end application in real time. This has been MongoDB.
In software development, MongoDB is becoming so much popular. When we talk about the MEN stack, which is one of the most popular stacks for software engineering, the M refers to MongoDB. So all developers are expected to upgrade to MongoDB. We also have what we call column family stores. Please put that in the chat for me. Column family store. Column family stores. Let's see that in the chat. An example is a database called Cassandra. You've heard DynamoDB today. You've heard MongoDB. You're also hearing of Cassandra. Cassandra uses column family stores, and this stores data in columns rather than rows? How in the world do you store data in columns rather than rows? All right. Instead of storing data in rows, like we call records in relational databases, with a column store, data is stored in columns, but they also have rows. Now the row is like the mother of several columns. The mother of several columns. And so if there is one row, the row is the ID. In the ID, to the right of the ID, we have several columns. And so I'll show you an example and you see how the column family works. That design allows for efficient storage and retrieval of large amounts of data. We also have graph databases. Please put that in the chat for me. Graph databases. An example is Neo4j. It stores data in nodes and edges, which is particularly useful for representing complex relationships between data. We'll see an example of that as well. So right now, we have seen that we have the powerful relational system, which if you don't know, you have to know. And then we have the NoSQL, and there are 4. And we have talked about their designs. And because of their designs, they scale better. On the video we watched, they said they use an example of a car like MongoDB that is ready to move at any time. Instead of joining a lot of metals before you move. And so in certain high performance environments, we need a design that is ready to move rather than talking to a lot of people, having meetings before you can move, because it slows down performance in some environments. As a tech professional, a software engineer, a data professional, you need to have an experience with both types of databases. We are going to watch another clip. After this clip, you will continue and soon get introduced to what we call DynamoDB from AWS. So let me share my screen again and we'll watch another video.
NoSQL databases have become very popular. Big companies rely on them to store hundreds of petabytes of data and run millions of queries per second. But what is a NoSQL database? How does it work, and why does it scale so much better than traditional relational databases? Let's start by quickly explaining the problem with relational databases like MySQL, MariaDB, SQL Server, and alike. These are built to store relational data as efficiently as possible. You can have a table for customers, orders, and products, linking them together logically. Customers place orders, and orders contain products. This tight organization is great for managing your data, but it comes at a cost. Relational databases have a hard time scaling. They have to maintain these relationships, and that's an intensive process, requiring a lot of memory and compute power. So for a while, you can keep upgrading your database server, but at some point, it won't be able to handle the load. In technical terms, we say that relational databases can scale vertically, but not horizontally, whereas NoSQL databases can scale both vertically and horizontally. You can compare this to a building. Vertical scaling means adding more floors to an existing building, while horizontal scaling means adding more buildings. You intuitively understand that vertical scaling is only possible to a certain extent, while horizontal scaling is much more powerful. Now, why do NoSQL databases scale so well? First of all, they do away with these costly relationships. In NoSQL, every item in the database stands on its own. This simple modification means that they are essentially key value stores. Each item in the database only has two fields, a unique key and a value. For instance, when you want to store product information, you can use the product's barcode as the key and the product name as the value. This seems restrictive, but the value can be something like a JSON document containing more data, like the price and description. This simpler design is why NoSQL databases scale better. If a single database server is not enough to store all your data or handle all the queries, you can split the workload across two or more servers. Each server will then be responsible for only a part of your database. To give an example, Apple runs a NoSQL database that consists out of 75,000 servers. In NoSQL terms, these parts of your database are called partitions, and it brings up a question. If your database is split across potentially thousands of partitions, how do you know where an item is stored? That's where the primary key comes in. Remember, NoSQL databases are key value stores, and the key determines on what partition an item will be stored. Behind the scenes, NoSQL databases use a hash function to convert each item's primary key into a number that falls into a fixed range, say between 0 and 100. This hash value and the range is then used to determine where to store an item. If your database is small enough or doesn't get many requests, you can put everything on a single server. This one will then be responsible for the entire range. If that server becomes overloaded, you can add a secondary server, which means that the range will be split in half. Server 1 will be responsible for all items with a hash between 0 and 50, while server 2 will store everything between 50 and 100. Theoretically, you've now doubled your database capacity, both in terms of storage and in the number of queries you can execute. This range is also called a key space. It's a simple system that solves two problems: where to store new items and where to find existing ones. All you have to do is calculate the hash of an item's key and keep track of which server is responsible for which part of the key space. Now in this example, the range of 0 to 100 is a bit small. It would only allow you to split up your database into 100 pieces at most. So real NoSQL databases have much bigger key spaces, allowing them to scale almost without any restrictions. Besides great scalability, NoSQL is schemaless, which means that items in the database don't need to have the same structure. Each one can be completely different. In a relational database, you have to define your table structure, and then each item must conform to it. Changing this structure isn't straightforward and could even lead to data loss. Not having a schema can be a big advantage if your application and data structure is constantly evolving. Now at this point, it's clear that NoSQL databases have certain advantages over relational ones, but that's not to say that relational databases are obsolete. Far from it. NoSQL is more limited in the way you can retrieve your data, only allowing you to retrieve items by their primary key. Finding orders by ID is no problem, but finding all orders above a certain amount would be very inefficient. Relational databases, on the other hand, have no trouble with this. Now there are workarounds for this issue, but only if you know how you're going to access your data, and that might not always be the case. Another downside is that NoSQL databases are eventually consistent. When you write a new item to the database and try to read it back straight away, it might not be returned. As I've explained, NoSQL splits your database into partitions, but each partition is mirrored across multiple servers. That way, a server can go down without much impact. When you write a new item to the database, one of these mirrors will store the new item and then copy it to the others in the background. This process might take a little bit of time, so when you read that item back, the NoSQL database might try to read it from a mirror that doesn't have it yet. Now, this is not a big issue in practice because data is replicated in just a few milliseconds, and if you want consistency, most NoSQL databases do have that option. So in summary, both NoSQL and relational databases will be around for the foreseeable future, each with their own strengths and weaknesses. So now you know how NoSQL works. Let's look at a few examples. Cloud providers heavily promote NoSQL because they can scale it more easily. AWS has DynamoDB, Google Cloud has Bigtable, and Azure has Cosmos DB. And to give you another example of their scalability, during Amazon Prime Day in 2019, Amazon's NoSQL database peaked at 45 million requests per second. That's mind-boggling. But you can also run NoSQL databases yourself with software like Cassandra, Scylla, CouchDB, MongoDB, and much more. Now, before ending this video, let's quickly talk about the name NoSQL. It's a bit confusing as it can have two meanings. First up, NoSQL can mean not only SQL, pointing to the fact that some NoSQL databases partially understand the SQL query language on top of their own query capabilities. And secondly, it's often called NoSQL in the sense of non-relational because it can't easily store relational data. So that was it for this video.
All right, so I want to believe that we are following and we are picking up some details from this. One part of this video that I like is how it explained the scaling. Scaling is something that we will talk about in this course and something that we need to understand for the CCP exam. We've heard that we have vertical scaling and we have horizontal scaling. Please put that in the chat for me and let's keep it in mind. The example that was given, comparing it to a building is wonderful. Keep that in mind and we will address it as we move on. So we have vertical and horizontal scaling. Thank you, Nyampandi. Thank you so much. All right. Now, each type of NoSQL database is optimized for different use cases and data models, reflecting the diverse requirements of modern applications. We will talk about common use cases for NoSQL databases. And after that, I will show you another clip. But when we say common use cases, examples here include chat applications, multiplayer games, IoT sensors, and these are real-time applications. Also, when it comes to content management systems, like managing blogs, media, or product catalogs, we saw this with relational databases, but it tells you that there are some things you can choose to use relational or non-relational. And there are certain things that relational is what you need, and other things you need non-relational. For NoSQL, we can also use it for big data and data analytics, for storing and analyzing massive data sets for insights. It can also be used for e-commerce, just like relational databases. So things like product recommendations, shopping cart management, NoSQL can also do that very well. When it comes to social networking, in terms of mapping relationships in social networking environments or user activity tracking, NoSQL can do this well. Let me share my screen and let's go online together and do some live research together and find out a little bit more about these database environments. And so, just like I said, just pay attention to the keywords in this particular lesson. Try and group them in your mind and know what is NoSQL, what is SQL, know what is unstructured and what is structured, and know where to use relational and where to use non-relational. And if possible, know the examples of non-relational database platforms and relational database platforms. For that, it is very important. For example, when they talk about MySQL, you have to know that MySQL is it relational or non-relational. Who can tell me? MySQL, is it relational or non-relational? Anybody in the chat? All right. So Wildom says MySQL is relational. All right. From what we've heard so far, MongoDB, is it relational or NoSQL? MongoDB, is it relational or NoSQL? So MongoDB is NoSQL. That is very good. This means you are making progress. In this lesson, as a beginner, this is what is expected of you. Try and pick out the keywords and try and put them in groups. That is okay for now. With time, you will get into details and you will explore them much deeper and experience them as well. For now, you are not expected to know everything about them. Just try and group them in your mind. So the question I'm going to ask ChatGPT is this. Tell me which of the two are good, the best, better, not good, obsolete, and bad between relational and NoSQL databases. Let's see the answer ChatGPT will give us. So ChatGPT is going to tell us something like, here's a comparison of relational or not relational database. Across different aspects that will help you. All right, so I don't want to, okay, so it's trying to group them, okay? It's trying to group them, but I don't think this is how I want the answer. Can you just explain in simple terms? Which one should I learn today? Now, if you are starting, learn relational databases first, like MySQL or PostgreSQL. They are widely used, easier to grasp for beginners, and great for structured data, like databases with rows and columns. Once you are comfortable and need to work with flexible, unstructured data like JSON, large-scale data, or real-time apps, then explore NoSQL databases. All right. So does it mean that none of them is better than the other? Let's look at the various responses. It says that neither relational nor NoSQL databases are universally better. Each excels in different, what do you see here? Each excels in different words. Let me see that in the chat. Different scenarios. All right. So that is what I'm telling you right now. They are not saying that one is better than the other. It depends. As a beginner, you need to start with relational databases and build an understanding of how databases work. And you can move on and learn about non-relational databases. Okay. Let's look at the recommendation. Start with relational databases to build a strong foundation in database management and querying. Once proficient, explore NoSQL databases to understand their flexibility and scalability advantages. This approach provides a comprehensive understanding of database technologies. Let me check the other response as well. It says exactly, neither is universally better than the other. They are suited for different purposes, okay? So for relational databases, they are better for structured data and applications requiring complex queries like financial systems and inventory management. NoSQL are better for flexible, unstructured data that operate in large-scale environments or real-time applications like social media and IoT. What do you see here? All right. So from experience, I am telling you that it does not mean that one is better than the other. What it means is that it depends on the purpose for which you need a database. And over here, ChatGPT makes it very simple. It says it depends on what? I've been waiting for someone to type it. It depends on what? Let me see the first person to type it. All right. Okay. Okay. Thank you. Well done. All right. Okay. So that clarifies a lot. And just like I said, you only need to understand the keywords and know how to map them accordingly. All right. Now we have DynamoDB, and this is what AWS wants us to study for the exam. We are going to discover what type of NoSQL it is. Before we do that, I'm going to play my last video on NoSQL, and after that, we will start talking about DynamoDB. So let me quickly do that, and we'll move on.
Hello people! You might have heard about SQL, which is a structured query language used to extract data from a relational database. Relational databases are usually stored in the form of tables, but in the real world, we want to store data in the form of documents, trees, and even graphs. This is where NoSQL or not only SQL helps. As the name suggests, NoSQL databases store the data in non-tabular formats. There are various types of NoSQL databases. Let's check them one by one. Key value database stores the data in form of key value pairs. The database contains unique keys and the values associated with those keys. We can query the database by passing the key, and the database will return the value corresponding to that key. BerkeleyDB, Dynamo, and Redis are some examples of key value databases. This type of database is often used for caching data. Wide column database stores the data into flexible columns, which can be spread across different servers. The query to find specific column values can be executed very fast. That is why it is also called a column-oriented database. Cassandra, Google Bigtable, and HBase are examples of wide column databases. This type of database is often used to store time series data. Document database stores data in the form of field value pairs. Values can be of any type like string, number, date, array, or even object. Document can be stored in the form of JSON, BSON, or XML. Amazon DocumentDB and MongoDB are examples of document databases. This type of database is often used to store PDF files in the form of JSON for better querying. Graph database stores data in which entities are related to each other. Information for entities is stored in the nodes of the graph, and the relationship between entities can be stored along the edges. Amazon Neptune and Neo4j are examples of graph databases. This type of database is often used for social networking applications. Overall, NoSQL is a very powerful paradigm for databases, and it is easier to scale.
All right, so we've heard a lot about NoSQL and the types of NoSQL, and we mentioned that there are 4 main types of NoSQL. I want to know who can remember all 4. I'm giving you 20 seconds to see if someone here can give us all the 4 types of NoSQL database. Okay, so William has started. Let's see who can give us all the 4. All the 4. So think about them. Let's see if you can give us. This is where the note takers will have an advantage. If you are sitting in class without taking notes, then you may have to struggle and remember. But those who are taking notes, you see, they have just produced it. Either says column family. Then we have graph databases, key value stores, and document databases. Beautiful. Louisa says key value, graph, document, and column family. That's good. Hilary says key value, document, column family, and graph. That's beautiful. Yvonne says document, key value, graph, column family. That's wonderful. Benedine says key value stores, document stores, column family, and graphs. Wonderful. Okay, so we are going to look at DynamoDB. And this is the first NoSQL database that we are discovering in AWS. And I like this so much because previously we've been talking about relational databases, and we've seen relational databases like RDS and Aurora. Now we are taking our first NoSQL database, and it's called DynamoDB. Now, DynamoDB is a NoSQL database service provided by AWS. This is the first thing you need to know about it. All right. So you are going to meet a question like, which of the following is a NoSQL database service provided by AWS? A, Amazon EC2. B, AWS Lambda. C, Amazon RDS. And D, Amazon DynamoDB. What is going to be your answer? What is going to be your answer? So Jael says D. All right. Yes. So this is how you should think. You need to first of all know that EC2, I think EC2 is a compute service. And so we are not even talking about compute. Although databases may use compute, they are talking about a database service. So what I would do is that I will start eliminating what are not. Lambda, not a database. RDS, it is a database, all right, but it is relational. Dynamo, yes, it's NoSQL. So keep that in mind, and that will help a lot. Then number 2, DynamoDB is a fully managed, it is also serverless, and it is key value and document database service. So you can see that Dynamo supports key value and documents. Now, most of the time we refer to Dynamo as key value stores, but it is both key value and documents. Tomorrow we'll look at another AWS NoSQL database service, and we'll get a better understanding of the NoSQL services. It provides fast and predictable performance with seamless scalability. Amazon DynamoDB is designed as both a key store or key value store and a document database to provide flexibility and meet a wide range of use cases. It is designed to handle large amounts of data with high throughput and availability, making it ideal for use cases such as web and mobile applications, gaming, IoT applications, and more. Key features of DynamoDB. Scalability, of course, it scales easily. It automatically scales up or down based on your throughput needs without any manual intervention. Low latency provides consistent single-digit millisecond latency for read and write operations. Wow. Single-digit millisecond. That's amazing. Serverless, no need to provision or manage servers. All right. So this is also serverless. So keep that as well. Security, it offers encryption at rest and in transit. We'll discuss all of these when we get to IAM and also VPC security groups. Global tables replicate data across regions with low latency and single-digit millisecond read-write latency. Wow. So with DynamoDB, data can be replicated across regions. So over here, you hear that it didn't say across just AZs. It actually replicates across regions. Built-in backup and restore, automated backups, and point-in-time recovery. Multi-region access allows replication of data across regions for this disaster recovery and low latency. All right. We will be taking a short break. When we return, we will learn more about DynamoDB. So let's take a short break, and I'll see you after the break. All right. So welcome back from the short break. We are talking about Amazon DynamoDB, and we've learned something about DynamoDB. We have understood that DynamoDB is a NoSQL database service created by or developed by AWS, and it uses the key value stores and the document-based database model. And we want to talk about the use cases of DynamoDB. Before we do that, I'm going to play a very short clip about DynamoDB. Let's watch it, and then we'll talk about it, the use cases, and the pricing model, and we'll wrap up for today. So let me share my screen now, and we'll watch the video.
You've just built a promising new app that the world has never seen before. New users are coming in, but can your database scale to handle all the requests? Amazon DynamoDB. It was built to handle internet scale applications at Amazon because traditional databases just weren't built to handle Amazon Prime Day's millions of requests per second. It's a fully managed service, so you don't have to worry about patching and upgrading your databases to the latest version. This means you can sleep in peace without being paged in the middle of the night. Not only are encryption and data recovery built in, but DynamoDB has an industry-leading service-level agreement. DynamoDB handles more than 1 trillion requests per day, and more than 100,000 AWS customers use DynamoDB. Get started today with DynamoDB, the hyperscale database for modern apps that need performance at any scale.
All right, so let's look at the use cases of DynamoDB. And number one, real-time applications. DynamoDB is ideal for instant updates, such as live chat systems and gaming leaderboards. For example, in a mobile game, DynamoDB stores player scores. When a player reaches a new level, the leaderboard updates immediately, allowing all users to see their new ranks. Then for IoT, DynamoDB handles real-time data from IoT devices like sensor readings and device states. For instance, in a smart home system, it stores temperature data. Any change triggers an immediate update, enabling automatic responses like adjusting heating and sending alerts. So these are IoT sensors. For e-commerce applications, DynamoDB manages product details, order history, and personalized recommendations. For example, an online store uses DynamoDB to store stock levels, prices, and images. It uses a global secondary index to quickly retrieve products by categories and provide personalized recommendations. For mobile and web applications, DynamoDB stores user profiles, session data, and personalized content, ensuring a seamless experience across devices. A mobile app, for example, uses DynamoDB to sync user preferences and session details across smartphones and tablets, so users can continue tasks from where they left off. All right, so all that this is saying is that DynamoDB can be used and is very, very good for real-time applications and for IoT devices like sensors, IoT sensors. It's also good for e-commerce and mobile applications. All right. For billing and pricing, DynamoDB offers flexible billing options to suit different application needs, including both on-demand and provisioned capacity models. So the on-demand pricing, we have pay only for the storage and the number of read-write requests you use. That is what the on-demand pricing means. So you pay for the storage you use and the number of read and write requests you use. The costs include $0.25 per million read requests and $0.25 per million write requests. There is no upfront costs or commitment. When it comes to the provision capacity, specify the number of read and write requests per second you need. Costs are $0.25 per hour for 1 RCU and 1 WCU. Tomorrow we'll talk more about that when we are talking about DocumentDB. Additional charges apply for data transfer out and across regions to global tables. Choose a model that best fits your application's need to manage costs effectively. So when it comes to pricing, it is very, very simple. Pricing is flexible and it has pay as you use on-demand model, and it also has the provisioned model. And the provision capacity, you specify the resources in terms of the compute or the infrastructure that it uses, and you are billed for that. All right, so I want us to see a real life demo of DynamoDB, and then we will wrap up today's lesson. Tomorrow, when we talk about DocumentDB, we will get a much better understanding. And so let's watch out for the next lesson. I'm going to share my screen again, and we'll watch the video about DynamoDB.
Welcome everyone. In this video, we're going to go through the basics of DynamoDB and we'll create our first table. Before we dive in to do that though, let's go over a couple of quick slides for concepts. As you might know, AWS has a lot of different databases, all purpose-built. DynamoDB falls into the non-relational or NoSQL category. In the big scheme of things, this is a newer way to store data. It's become really popular in recent years for high-traffic web apps, e-commerce, and gaming. These have a much more flexible schema than, say, the Relational Database Service or RDS. Link above and below, by the way, if you're interested in that video. But it's easier to scale, and generally you're going to get better performance. Here, rather than storing your data in tables with rows and columns, it's commonly represented as JSON code, as you can see here in this example. Here we have information about a person, Jeremy Dunn. It supports arrays like the hobbies listed here, and you can also nest data like the address information. In general, this schema is much more flexible than a relational database schema. If I wanted to add a new field or key for, say, occupation or favorite food, I would just do that. It's much harder to make schema updates in a relational database, but not here. DynamoDB is a key value database, which is one of the more popular forms of NoSQL. If you're not familiar, it essentially works like this. You have a unique set of identifiers that have associated values. So basically 2 pieces of data that are associated with each other. All right, enough with the talk. Let's go and create our first table. In the console, navigate to DynamoDB. And as always, we have the big orange button to get started, so we'll say Create Table. Now I'll point out here we're creating a table, not a database. With RDS, we had to provision the instance for the database, which installed some default databases. Then we would actually have to go create our own database after that, which would hold tables. But here we're just creating a table right away. Because DynamoDB is serverless, all of that underlying infrastructure is being handled for us. All right, for table name, we'll say customers. For partition key, this is part of a unique identifier that will let us retrieve items from the table. Here we're going to say customer ID, and the data type will be a string. A sort key is an additional thing you can specify optionally that lets you sort and search. We're going to skip through this one though. For settings, we'll go with default settings, and then create table. All right, let's click into the customers table. And then up here on the top right, explore table items. We don't have any items at the moment, obviously, so let's create item. We specified the partition key of customer ID. I'll just enter 1 for that value. Then I can also add new attributes from here. So let's add a new one for string. This will be first name, and let's say the value is art. And then another attribute for last name, Vandelay. We'll add an attribute for city, and let's say that's Seattle, and then one more for state, and that will be Washington. All right, now let's create this item. Then down here, under our list of items returned, you'll see that the schema is basically inferred from those attributes that we entered. So city, first name, last name, and state. Let's create another item. This one will be customer ID 2. We'll add an attribute, first name, Bob, last name, Sacramento, and let's go with a number here for age of 62. And create item. So now you'll see that we have the 2 items here, and they have different values. The second one I have an age, and the first one I didn't. The first one I had city and state, the second one I didn't. And all of that works just fine in this non-relational database schema. It's a very flexible way to store your data. We're just putting the data here on the table. We aren't having to join it and set up relationships and so forth like we would have to in a relational database. So that's how you create a DynamoDB table and add a couple of items. If you found it helpful, I'd really appreciate you hitting that like button so it can spread to more people. And also think about subscribing for more content like this. Thank you so much for watching.
All right, so thank you so much for watching, and thank you for attending the class. Tomorrow we'll continue our study on NoSQL databases. We will talk more about it. We will understand it much better and have a clear understanding when it comes to the NoSQL services in AWS. So let's prepare for the next lesson and our quiz on Amazon Aurora. I'm going to see you tomorrow. So have a great day, sleep well, keep learning, and prepare for tomorrow's lesson. Thank you very much, and I'll see you in the next lesson. All the best. Bye-bye.